Hello everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equations. So let's get going. Problem. Form the partial differential equation by eliminating the arbitrary constants from z equal to 2x square plus a into 3y minus b. Here, a and b are arbitrary constants, x and y are independent variables, z is a dependent variable, z is a function of x and y, where x and y are independent variables, we can say. Right. Now, here in our problem, we are asked to find the partial differential equation by eliminating the arbitrary constants a and b from the given equation or the relation. Given z equal to 2x square plus a into 3y minus b. Consider it as equation number 1. Let's partially differentiate 1 with respect to x. So here firstly we'll see the detailed process of the problem, and later we'll see the shortcuts just by decreasing the number of steps while partially differentiating the equation with respect to x and y. Okay. Here apply dou by dou x on both sides of the equation. Since we are partially differentiating with respect to x, so y will be treated as constant. 3y minus b is completely treated as constant here, okay, because it involves y and b, which are constants. Well, this gives us dou z by dou x equal to constant 3y minus b into dou by dou x of 2x square plus a. Since dou z by dou x equal to p, so let's replace the LHS part by p. We'll get p equal to 3y minus b into partial derivative of first term plus partial derivative of constant a. This gives us p equal to 3y minus b into 2 into dou by dou x of x square plus partial derivative of constant with respect to x is 0, which gives us p equal to 3y minus b into 2 into partial derivative of x square with respect to x is 2x. We can write this as p equal to 3y minus b into 2 into 2x is 4x. Now bring this 4x to LHS, you'll get p by 4x equal to 3y minus b. So you can just leave it like this, but what I did is I just observed 3y minus b in the question, right? So by looking at the question, we can say that we can just replace 3y minus b by p by 4x if we bring this 4x to LHS. Okay, it may be useful. Okay, fine. Now consider as some equation 2, or you can just write it as 3y minus b equal to p by 4x. Let's see. Now partially differentiating 1 with respect to y. Let's partially differentiate 1 with respect to y. We'll just apply dou by dou y on both sides of 1. Since we are partially differentiating with respect to y, so x will be treated as constant here. And here 2x square plus a is treated as constant since x is constant and a is also a constant, right? Now we'll write this as dou z by dou y equal to constant 2x square plus a into partial derivative of 3y minus b, which gives us, since dou z by dou y equal to q, we'll use this notation and replace the LHS part by q. You'll get q equal to 2x square plus a into 3 into, yeah, we can write one more step. Okay, partial derivative of first term minus partial derivative of second term. This gives us q equal to 2x square plus a into 3 into dou by dou y of y minus partial derivative of b, that is constant with respect to y, is 0, which gives us q equal to 2x square plus a into 3 into partial derivative of y with respect to y is 1, which gives us q equal to 3 into 2x square plus a, right? Now bring this 3 to LHS, you'll get q by 3 equal to 2x square plus a. Consider as equation number 3. Now observe 1, 2 and 3. By observing 1, 2 and 3, we can say that using 3, 2x square plus a can be replaced by q by 3, and using 2, 3y minus b can be replaced by p by 4x, right? So that the arbitrary constants a and b gets eliminated, right? Now substitute. We have 1 z equal to 2x square plus a into 3y minus b. Substitute 2 and 3 in 1. We'll get z equal to, using 3 we can just replace 2x square plus a by q by 3, and this can be replaced using 2, p by 4x, right? You'll get z equal to pq by 3 4s are 12x, or just bring this 12x to LHS, you'll get 12xz equal to pq, or pq equal to 12xz, which is of the form, the equation is of the form f of x, y, z, pq equal to 0, right? It does not involve any arbitrary constants, right? So this is the required partial differential equation, which completes the problem. Now let's see the same problem by decreasing the number of steps. We are given an equation z equal to 2x square plus a into 3y minus b, right? Let's partially differentiate it with respect to x. We'll get dou z by dou x equal to, since we are partially differentiating with respect to x, right? So y will be treated as constant. Totally this 3y minus b is treated as constant, okay? Into 2 into partial derivative of x square with respect to x is 2x plus partial derivative of constant with respect to x is 0, which gives us, now use the notation dou z by dou x equal to p. We'll get p equal to 2 2s are 4, 4x into 3y minus b, which gives us p by 4x equal to 3y minus b. We have considered as equation number 2, right? Now partially differentiate one with respect to y. We'll You'll get dou by dou y equal to constant 2x square. Since we are partially differentiating with respect to y, so x will be treated as constant into 3 into partial derivative of y with respect to y is 1 minus partial derivative of a constant with respect to y is 0. Use the notation dou z by dou y equal to q and replace it by q. You'll get q equal to 3 into 2x square plus a, which gives us q by 3 equal to 2x square plus a. Consider it as equation number 3. Already we have considered as 3, right? Now observe 1, 2 and 3. By observing 1, 2 and 3, we can say that by substituting 2 and 3 in 1, the arbitrary constants a and b gets eliminated from 1. Substitute 2 and 3 in 1. I get z equal to, using 3 you'll get q by 3, using 2 you'll get 3y minus b, p by 4. Just you can replace 2x square plus a using 3 and you can replace 3y minus b using 2, right, which gives us pq by 12x. Now bring this 12x to LHS, you'll get 12xz equal to pq or pq equal to 12xz. Since this is of the form f of x, y, z, pq equal to 0, right? We can say that this is a required equation since it does not involve any arbitrary constants also. Therefore, pq equal to 12xz is the required partial differential equation. Well, we have seen a problem from partial differential equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.